Hello everyone, in this video we're going to be solving a nice rational equation. We have x squared plus 4x squared divided by x plus 2 quantity squared equals 5, and we're going to be solving for x values. I'll be presenting two methods, and let's start with the first method. So for my first method, I'm going to do the following. I'll be using substitution. Let's go ahead and write the 4x squared as 2x quantity squared and x plus 2 squared as x plus 2 squared. So we can go ahead and write this as the square of a quotient, and that's equal to 5. Great. Now at this point, I want to use substitution and go from one variable to two variables. That might seem like a dumb idea, but sometimes it's helpful for solving equations. So let's go ahead and call this y. And we get x squared plus y squared equals 5. And then, since we call that y, let's go ahead and simplify that expression a little bit. 2x over x plus 2 is equal to y. This implies 2x equals yx plus 2y. And then what we can do is we can go ahead and put the x and y together, like 2x minus 2y is equal to xy. So we kind of came up with a system of equations like this. Xy is equal to 2 times x minus y, and x squared plus y squared is equal to 5. So that's going to be my system. And to solve the system, we're going to use some identities. Now, why did we go from a single variable to two variables? Because solving the system is actually easier than solving this equation with a single variable. So notice that x minus y and xy are related by this equation. So if you go ahead and square x minus y, you get x squared plus x plus y squared minus 2xy. Great. So since we do know that x squared plus y squared is equal to 5, we can go ahead and plug it in and write this as x minus y squared is equal to 5 minus 2xy. Now, along with this, we have another equation that relates xy and x minus y, which is this one. So let's go ahead and put it together. What can I do? I can basically replace xy with 2 times x minus y. So x minus y squared equals 5 minus 2 times xy, which is 2 times x minus y. So that becomes 2. If you want, you can go ahead and call this d for difference. Since that's a difference, we can write it as d squared equals 5 minus 4d. And then d squared plus 4d is equal to 5. If you dealt with quadratic equations before, you probably know that d is equal either 1 or negative 5. Okay, you can easily find those from here or by factoring or by using the quadratic formula. However you want to do it, there's going to be two solutions for d. And d represents, or d is represented by x minus y. So now we have two values for x minus y. But since xy and x minus y are related, that means xy can be found, which is just 2 times that. So from here, xy becomes 2, and from here, xy becomes negative 10. And guess what? That gives us another system, or two systems, which we can easily solve, right? And then from there, we're going to find the x and y values. Let's go ahead and do it. So one of the equations is x minus y is equal to 1. And xy is equal to 2. Let's go ahead and solve this first. Let's call this the first equation, and then we're going to solve the second equation next. Okay? How do you solve it? Well, if you can think of two numbers real quick, then you're good. The difference is going to be 1, and the product is going to be 2. So do you think 2 and 1 will work? I think so, right? If x is 2 and y is 1, then this will work. So 2, 1 is a solution, right? Obviously, x equals 2. But can they switch around? No, they can't. But here's the thing. We should be able to find another pair, right? That satisfies this, because there must be another value. And you know what I'm thinking? If you replace x with y plus 1 and plug in here, you should get a quadratic, which indicates there should be two solutions for x and two solutions for y. So think about it. Can they be negative? Absolutely. Negative 1 and negative 2, but their difference has to be positive. So we have to x must be the larger number. In other words, x is negative 1 and y is negative 2. That's also going to work. Make sense? Great. So those are the order pairs that we get from the first equation. Let's go ahead and take a look at the second equation. X minus y is negative 5 and xy is negative 10. This may not give us integer solutions. I'm just guessing, because when I think about two numbers whose product is negative 10, I don't think their difference is ever going to be negative 5. We can still test it, like, okay, one of them has to be negative, so 1 and negative 10, 2 and negative 5, 5 and negative 2. I don't think these will work because their difference will never be negative 5. So we probably have irrational solutions. Let's go ahead and find out. Let's replace x with y minus 5 here. So y times y minus 5 is equal to negative 10. Or we could have non-real solutions too. Y squared minus 5y is equal to negative 10. So let's just add 10 to both sides. And from here, y becomes negative b plus minus the square root of b squared, which is 25, minus 4ac, which is 40. Yes, that's going to be complex solutions. So from here, y is going to be 5 plus minus the square root of 15i divided by 2. And how do you find the x values? X values are just going to be 5 less than this. So in other words, if you subtract 5 from each of these solutions, you're going to get the x values. And suppose you did it like this. Subtract 5. So in other words, you're subtracting 10 from this because you're dividing by 2. That's going to basically give you negative 5 plus minus root 15i over 2. Those are going to be the x values. Make sense? And this brings us to the end. Well, it doesn't bring us to the end of this video because there's another method we need to talk about. I forgot. Second method. Okay, let's quickly do that. Second method. I almost finished the problem. Okay, with the second method, we're using a different approach, a very different approach in my opinion. We're going to go ahead and do this. Again, this kind of uses substitution, but in a different way. So I'm thinking about the sum of two quantities squared. So what happens if I square this, right? I get something like this and then something else. But squaring this, actually, there's a better way to do it. I want to subtract, I want to square their difference. And I'll tell you in a little bit why difference is better than the sum. So first of all, if you square this, you're going to get x squared plus 4x squared divided by x plus 2 squared, which is what we have. That's 5. Minus the 2ab term, right? So that's going to be 4x squared over x plus 2. And obviously, this is going to give us something super duper nice. Why? Let's go ahead and make a common denominator and see what happens. X squared plus 2x minus 2x divided by x plus 2. And we're supposed to square it. And this is where the magic begins. 2x cancels out. That's why we want to use a minus sign, not a plus sign. Make sense? You have a choice, but you have to choose wisely. So this becomes the following. X squared over x plus 2 squared equals, from here, that's a 5. And this is what it is, right? Now, looks like this equation is not solvable, is it? It actually is. If you expand it, don't do it because you're going to go back. By the way, a third method could be expand everything and deal with the quartic. That's not a good idea, but you can do it if you want. That will be the third method. But here's we find something interesting. Look at that. They are the same. So we can use substitution. Let's go ahead and call this t, because t is fun. T squared equals 5 minus 4t. T squared plus 4t is 5. Okay. 4t, 4 times t. And then from here we get t equals 1 and t equals negative 5 as before. But what is t? X squared over x plus 2 and x squared over x plus 2. It's a little different because we're not using two variables, or only single, sticking with the single variable. This gives us x squared equals x plus 2. And from here, as you know, x equals negative 1 and x equals 2 are solutions. Negative 1, right? And from the second one, I believe you do get the complex solutions as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.